Yeah, thank you, John. And thank you for the introduction and welcome everyone. So look, today's webinar, I'm going to follow on from Phelpsy's previous previous presentation. We promised you a deep dive into the systems today, so I will pick up from there. I worked with David and Sally Lago in the Precision Pastoral Management Tool process, which research program which Phelpsy has just been speaking about. So within the eBeef program, what we have aimed to do is actually pick up the research and pick up the tools and the algorithms developed within that program and bringing it across and demonstrating it on the six eBeef properties. So the data that we'll dive into today will be focused on an actual live data from particular sites within the beef project, so it's relevant to Queensland producers. Just one thing to state from everyone else that is on the system from other states. This information, what we found, exactly what Dave said, is that it does translate over to NDVIs in many other systems, and we also had a southern temperate system running at the same time, which the research translated over to nicely as well. I'll just start the presentation by focusing on walkover weighing. People might be familiar with walkover weighing and auto drafting, which is the product that was commercially released at the last Beef Week to the industry. Today I'm going to focus very much on the weighing rather than the weighing and drafting, mainly because it's the weight data that delivers value to the NDVI. So what we'll actually do here today is I'll take you through some actual NDVI data, some live weight gain data on a property in North Queensland, and show you how these two data sets are interacting to be able to make management decisions. So the Weigh Crate platform for the walkover weighing is basically what you see there. It's solar powered. It turns up equipped, ready to run, and is also linked with telemetry. So basically, what happens is animals cross over the platform, reads their RFID tag. The system's solar powered, so it can run 24/7, and then it remotely sends the data up nightly back to the software where it's collated and reported on at that point. How the system is then deployed, and I really just want to focus on the walkover weighing only deployments within this presentation, be it that 90% of our deployments are WOW only deployments, especially through Queensland. And the reason being is that the drafting units require trap yard setups, which are mostly found in the more northern properties across the country, where the majority of our units are sort of central Queensland, northern New South Wales, in that sort of central zone where traps aren't typically adopted. The other reason I want to focus on walkover weighing only is that there is very little to no physical training of the animals as well to adopt the technology. Animals train themselves, and it's just a portable panel electric fence setup process to educate animals to go over the system. They teach themselves how to use the system over about a 3 to 4 day period in this particular mode. So in this particular deployment, this is as basic as the system needs to be. We just need an attractant of some description, whether it be water or a supplement or a lick bag or something in there that animals particularly want. And then we just put we can either portable fence it off, or we can use electric fence, and it's just the attraction for animals to walk in and out through an opening. And every time they do, we're able to collect their weights and transmit those up to the software. Just a little bit of an insight of how animals teach themselves to use the system here. Basically, for the first few days, all we do is set up this ring, whether it be electric fence or portable panels, and leave a 2 metre gap beside the unit. So the animals just all they're teaching themselves in the first few days is that they can only attack the water from one direction, and then we pull this across, and animals start crossing in and out over the platform on that front. As you can see, this is a very typical central Queensland type deployment here. As you can see, it's Downs country with a bit of red country off in the background there. So this is I would say, with all our deployments that are out there across Australia, this makes up probably about 85% of our deployments in this method across Australia. Now, one of the misconceptions that I do want to, just in all these presentations, I try to address is that one of the major thoughts is that people believe that walkover weighing needs to be deployed on every water to be effective, and that's simply not the case. What we found within the PPMT research was that we could strategically drop units in on certain areas and just get a subset of animals cross over it to be able to get very effective herd management data. And that information is things like weight gain, kilos of beef produced, the distribution of the herd for making trucking or sale decisions. But for instance, this was one of the research properties that the PPMT was working with at the time, and with a very similar type. And this is a very typical northern beef deployment where you have some channels around the place. But basically, we're able to, any one of these paddocks had multiple waters. Basically, all we needed was an attractant or a water that majority of the animals do go to at some point in time, and then the system can be deployed as in that previous photo. So, for instance, here in this middle paddock here, we can deploy the system here on this blue dot, and we found that in that particular scenario, in these particular herd average scenarios, that well over 60% of the animals do rotate through that areas. Quite amazing, a lot of the behaviour that we found along behind these systems and the way that animals interact with trough water. It does definitely seem to be a meeting place or the pub of some description for animals. We had one deployment in the Northern Territory on the Barkly that during the wet season the property had to keep the troughs on because animals would walk through water to go and drink out of the trough. So we do find that trough water and then even supplements are a very strong attractant to getting animals in and out through the system. But the takeaway here is that to get the herd average data and the herd distribution data, we don't need every animal crossing the platform. We just need to sit it in a strategic place. Just quickly show you what the data starts to look like on your dashboard as it's coming back from the unit. So this is just the live weight data only for this particular deployment. So basically what it does is it gives you a quick snapshot, and the data's collected daily data's collected by the hour, reported or sent up nightly, and then the information's reported weekly. Is each one of these blue dots is the weekly herd average of the group, and then each night at midnight it sends up the previous day's data and can give you a snapshot of who's actually at that particular water, how many animals are at that particular water yesterday, last 3 days, and last 7 days. So if you're in a situation where you're doing a rotational grazing and you may only have one water in the paddock, obviously you can start to see that all your animals are there. However, if you're in a larger paddock with multiple waters, it'll tell you how many animals are watering at that particular water point in the last 7 days. And then, and then each click into the software takes you further into the data set. So we can see here that on the herd average is the animals are gaining weight, hit to a point where they started to tip over, and this is what we sort of call the stall date. So in any particular wet season, dry season system that we work in, we see that animals will gain weight to a certain period of time through the year, depending on how much rainfall there has been, and then move into a negative play nutrition, and then it rains again, and then we get a kick in growth. So that's again on the herd average, but then we can click in and drill in on the individual animal as well. So we're able to drill in and go to an EID, and we can sort and filter this data based on many different traits. So if you want to have a look how a certain breed is doing, or a certain group of animals that you've added the information or its life data information against EID, you can look at as many subgroups as you wish, just by pushing the data around within the system. So that is just the live weight data by itself. But really what we're here to talk about today is actually how do we combine the satellite data with the live weight data to make management decisions and get insights. Picking up on Phelps's presentation previously, this was the PPMC project's objectives that we set out to achieve, and basically in this simple cartoon was combining satellite technology, combining the live weight data, and then bringing that back to a dashboard or a tool that will give the manager of the station the ability to make decisions, and those decisions, as Phelpsy outlined, things like marketing, supplementation, and paddock changes, those type of things, NRM outcomes. So I'm just going to give you a rough idea of actually how the algorithm sort of starts to come about and how it actually makes ties these two data sets together. What you're looking at here is pretty much exactly what David had put up previously. Is that I've got here graphed there are 5 years of NDVI data here on this particular graph. And you can see that you can pick any one year. We'll pick the yellow line because it stands out nicely at 2018. This is a paddock that is in the EB program, and we can see that the start of the year for 2018 it was a pretty dry start. There wasn't any rain, and then February they got a kick and rain, and then the stalling or the decline of the NDVI then running off. Hitting a tail and just tailing out until the next wet season. So we can see there, we can just map year on year and start to understand how satellite data behaves at various times of the year, right back to I think it's 2000. I think is where this is modus data. So we've got history right back to 2000 on that particular paddock, or any of the paddocks across Australia on that front, that is able to be accessed via modus. So the second part of that particular data is that we've also then got the average growth for live weight gain as well. So this was last year's data from one of the EB sites. We can see the animals were growing. They hit this sort of plateauing that David pointed to in his previous presentation, and this is what we call the stall date. So this is the growth rate stall date here, and then just depending on the season, those animals will then tip over into a negative plain nutrition. Now these are steers, so these are dry animal equivalents. So we're able to get a really good idea here of what these animals are performing, how many kilos they're growing. But more importantly, what the technology is doing is it's mapping this growth against the NDVI. So basically, the cattle live weight is training the system to know that what the NDVI means, essentially, in as far as kilos of beef grown are concerned. Once the algorithm is able to be trained, and we only need really one dry season's worth of data to start the training of the algorithm. Basically, at this point, we can start to make forecasts. So because we know what an NDVI signal means in kilos of beef grown, that means we're able to pull a forecast line together. So what you're seeing here in this particular graph is the green line is actual, and the orange line is the forecast from the system. So this is the forecast that based on the history of this particular paddock and the way that paddock behaves after rain. It's basically saying that, okay, on the system on the 18th of the 2nd made a forecast saying that this is the actual NDVI. We've hit peak green, as David spoke about, with the systems going over. It's triggered a forecast, and this is where the line is expected to go up to up to now, basically. Also, within this information, we also have a forecasted cattle stall date. So this is the forecast has said that this will be the date those animals will move into the plateauing of their weight gain, and that's just to reiterate, is just this point here, which is what we call the stall date on that front. So what our goal is in the EBs is to pretty much just test these forecasts. So we forecast and then let it run forward. So that was the forecast. This is now the actual. So as we can see, the NDVI has continued. I took this, built this graph a few days ago, as we can see here, the green line is the actual and how the months have progressed, and the orange line is the forecast. And as we can see, that the forecast has held quite true all the way down. It's a very close sort of fit down through here. This red line was our forecast growth date running out, and this blue line here is the animal live weight over that particular time from the walkover weighing unit. Now, it's not very easy to see here, but within this live weight gain, we can actually see the animals plateauing here, and that was within a week of the forecast date. So what was very encouraging within this project was that our researchers held true from the PPMT, that we're able to forecast within a week either side of the stall date, and it actually be correct as then the animals are hitting their stall date. So this allows us to be able to give us confidence, and the idea is to demonstrate confidence that we can be making decisions with plenty of notice here to know when this cattle stall date will occur. And those decisions may be, this is the date we need to order supplementation. So you've got months of warning and the ability to then go out and optimally purchase potentially supplementation. The big one that we're focused on as Datamars is actually providing the ability to, or this forecast, the ability to be able to help you lock into forward contracts with a lot more visibility, but a lot more confidence. So to give you the confidence to say, yes, we will go and lock into a forward contract for X amount ahead, because we can see that we've got the cattle in the paddock, we can see the live weight gain, and we can work out where these animals are most likely to be at that forward stage in time. So that's a real focus for us as a product. But then as very much of also using this information more on a paddock scale across the property to actually definitely see what paddocks caught more rain than others. So that very much may make the decision to do a paddock change based on that one paddock either got some out of season rain or got more rain to be able to keep that cattle live weight going. The other thing that we're able to do once the algorithm has enough data to be trained is that we now know what these values mean as far as cattle live weight increases. So we know that what this event equals in how many kilos grown. So what that enables us to do with our forecasts is not only forecast the stall date, but we're able to forecast how many kilos that paddock is likely to produce, or those animals in that paddock are likely to produce. And again, this is on a dry animal equivalent on that front. But more importantly, there's a couple of ways the system does this. If you have an induction file or just straight based from the walkover weighing data, it's more importantly can forecast the likelihood of how many animals are going to be within certain weight ranges in that 2-3 months down the track. Now, this is quite important for us, and what we believe, and the feedback from our partners have been is that we really want to be able to forecast what the distribution looks like, so we're able to lock in certain amount of animals into a contract 2, 3, 4 months out. And this is where we really do find the ability to possibly gain, that extra 10, 20 cents to on your market price, but being able to lock in with confidence. So one thing we hear a lot from our clients is that we would like to take advantage of more forward contracts, but we just simply don't know what's in the paddock or whether we're going to be short or over. So that's a real focus, I suppose, that we as Aldermars are looking to use the technology for going forward. Just picking back up on the question about how information can be extrapolated over paddocks or over properties, or over neighbouring properties. Practically, what we've found through the research, as David mentioned, is that we don't see these figures cross over very well to neighbouring properties. However, within a property boundary, what we have found is that we find that these figures cross over quite well within the land types on the property. But for instance, if you have a look at this particular map, we've got a lot of this is just a land type map. We can see we've got a lot of red country out here and a lot of channel and some downs country out here. Information collected from the system out here on this land type doesn't translate to the red country. So the practical deployment that we found for this particular property or any property that has multiple land types is that what we will be doing is actually running multiple systems. So we would have one walkover weighing system somewhere out here in these land types, and then we're able to use that information and extrapolate quite accurately across the land types. And then we'd also have one system running in the red country, and then that information can then be extrapolated across the land type. The red country land type. So as David pointed out, you do have to be very careful with how you do your extrapolations, but we did find that within property boundaries and across land types, similar land types, that extrapolation is very, very useful, especially trying to understand herd growth or what the average weight in that paddock will be based on how much rain that particular paddock received, but also then predicting what the distribution or what the weight gain and the weight distribution of that paddock will be for marketing purposes. But that pretty much pulls up my presentation for today.